So mostly today in this session, we're gonna do an activity. This is a sample activity that my colleague Kimura Haskell and I developed for a new class that actually I just started this spring, a new class that we called Foundation of Mathematics and the Acquisition of Mathematical Knowledge. We developed that class and taught it this past spring at the University of Southern California. And I will come back at the end on why that class, and maybe also listen to some of your comments of ideas and suggestions. But just real quick, so this class called Foundations of Mathematics and the Acquisition of Mathematical Knowledge. At least I can tell you one short goal, which relates to Michael Starbutt's talk last night in some ways, which is we wanted students to go back at those fundamental concepts of mathematics that are taught from K1 through K12. And we wanted them to go back to them and then have a look at those concepts, maybe with a more mathematician-like approach and mindset. So that would be one of the goals, but there were some other goals behind. Just real quick, this class, we had 11 undergraduate students enrolled. 10 of them were math majors or minors. One student was a business major. We actually had decided to have no prerequisite for that class, mathematically speaking. We also had 8 pre-service teachers that were enrolled in the Masters of Education program from the USC School of Education. And all of them actually also happened to be in the Math for America program. The class met twice a week for 1 hour, 20 minutes, and all the class time was IBL style, and all the activities were IBL style. So that's how it went during the class time. And one more thing, which was, I think, a big component that actually a lot of our students really appreciated, is that we also partnered with a local high school, and each of our USC students were paired with a high school student, one for some of them 2, and kind of establish that mentor-mentee relationship for the whole semester. Our students would go to the high school once a week, and they would work with those high school students, the same ones, every week for an entire semester. And so the whole point was not, I want to insist that it was not tutoring, it was mentoring, it was math mentoring, all right? So those are just like the quick setup of the class. But mostly what I wanted to do is actually kind of, go through like a short version of one of the activities we did during that class. So there's going to be so I just want to make sure you all have a piece of paper. We'll need scratch paper. I have some if you need some, and a pen. And you're going to have to work in group. So hopefully you're willing to talk to each other. If not, you can still run away. It's fine. All right. So the activity is going to be so the topic is introducing multiplication and division. I'm actually, to be honest, I'm lying a little bit. I think for time reason, we're only going to do division. So I will assume you know how to multiply. And we will restrict ourselves to positive whole numbers and positive rational numbers. All right? We'll avoid the irrational for today. And for the next about 5 to 6 minutes, I would like you to come up in groups with at least 3 very short 2-line stories that involve doing a division of whole numbers or rational numbers. A very short 2-line stories, but you have to do a division, or your story may end up with a question that is a division of whole numbers or rational numbers. If you really want an example, I don't want to bias you in any way in terms of, I should really not do that, and I didn't do that, but just to make it faster. Here is an example that actually some of our students came up with, which I thought was kind of hilarious. It was actually one of the teacher students that came up with that example. Ooh, that's terrible. You should have told me that. I will just read it for you. The example was, if I cry 24 hours a day and I wipe my tears every 4 hours, How many times a day do I wipe my tears? That was a teacher student. All right? So here you go. I'm giving you 5 minutes, and I would like, at least in terms of groups, maybe one row can be a group, to come up with at least 3 stories about divisions that involve a division. Picked a peck of peppers in one day. How much pepper peck? Peter, is that a Peter? Right? Picked in 1 hour. How many 3-egg omelets can I make with 18 eggs? You operate a shoe shine and have 12 tubs of polish. If one shoe uses up a 4th tub, how many shoes can you shine? Story number 4. Mary likes to run 3 miles per day. The track she runs on is 3/4 of a mile. How many laps does she need to run each day? Pete is painting an 8-foot-long fence. He paints 1/4 of a feet per minute. How long will it take to paint the fence? Danielle and Michelle, or Michael or Michelle, can't tell. You have 7/4 yards of ribbon. Each hair bow requires 5/9 of a yard of ribbon. How many hair bows can you make? Hair bows or hair bows? Hair bows. Bows. Here you go. The classic. It takes 3.5 years to knit 1 blanket. After 10 years, how many blankets have I knitted? And we have 6 cups of water to make orange juice from concentrate. If each serving uses 3/2 cup of water, how many servings can we make? If you have 2 cups of yogurt and 1 serving is 3/4 of a cup, how many servings of yogurt do you have? You have 7 yards of ribbon again to make bows on dresses. Each dress requires 3/4 yard of ribbon to make a bow. How many bows and dresses can you make? All right, now I'll give you another 4 minutes, and I want you to try to kind of group those stories in however way you think they are similar. Think about what makes them different, what makes them similar, and try to group them by similarities, whatever your criteria are. I'm not going to ask you to do them in 2 groups or 3 groups or 4 groups. It's up to you to decide whatever similarities you think they have or how different they are, and kind of put them in different bags. All right, I'll give you 4 minutes to do that. And ideally, you obviously want to have your, as you're doing this, you want to try to be able to explain what your criteria were for putting the stories together. So in the actual class, we would have, first of all, in the actual class, we would have walls of papers with many examples. So we would have a huge sample of examples, right? Here we only have 10 of them, which is already good, but we had many, many, many more in the actual classroom. And then, therefore, they also had they also spent a lot of time trying to classify them all, and you know, some of the students came up with two categories, and then revisit that, and then came up with 3 categories, and so on. So it was a very interesting way to see how they were going back and forth, you know, trying to come up with some criteria, and then they would change the criteria as they would go along, because they realized, oh, maybe this is not so great. So it was a very interesting interesting thing to watch, and I want to. So I'm going to completely ignore what you did and not ask you about it, even though I kind of went around and tried to ask you at least how many groups you can get. And it is true that it. Did anybody get 3 categories? No? You kind of did? sort of? All right. Oh, 3 or 4. Uh-huh. You could do that. You could do that, right? I did not really, again, I did not try to impose any, you choose your own criteria. Obviously, we want to go towards mathematical criteria, right? And so let me just show you, so after a lot of discussions, here are the 3 categories that the class ended up coming up with. So after they all discussed that in groups and then discussed that as an entire class, and they decided to come up with 3 definitions. I'm going to show them to you, what they came up with. I should have highlighted my adds-on that, obviously Jones did not name. The first category, they say the quotient C divided by B is the measure of what is obtained when something of size C is divided into pieces, each of which has size B. So C divided by B is the measure of what is obtained when something of size C is divided into pieces, each of size B. So they also talked about units. That's what's underneath behind. They kind of said, well, like C has whatever units it has, but then the units of B has some other units divided by the units of C, and the units of A, which is the quotient, the resulting quotient, the units of A are those of C, I believe. Right. So what I added on is that, so this is actually a model called the measurement model of division. Maybe some of you have heard about that. All right. The second definition they came up with was now, here we go, the size of each piece when an object is divided into B pieces. C divided by B is the size of each piece when an object of size C is divided into B pieces of equal size. All right. And they also kind of they did make some type of dimensional analysis on that too somehow. And this, by the way, is called the projective model. All right. And then the last definition they come up with, this one, so they had done multiplication before. So this is harder to come up with, especially in those examples, but since they had done multiplication before, they thought about it. And finally, the quotient C divided by B is the length of one side of a rectangle when the area is C and the width is B. All right. Here's the third definition they came up with. All right. So those are the three groupings they did, which give them 3 models for division. This, I think, they thought about it because we did multiplication. We had done multiplication before, and that's probably what inspired that decision from them. Last thing, so, so especially when you're looking at the definition 1 and 2, so they are very, they're, I would say, fairly known definitions of divisions. And they came up with it on their own, kind of looking at all that your sample of examples. And I thought that was really good. To be noted that obviously as you go in away from the whole numbers, those models, the line becomes blurry, right? So the next exercise that they did, and you don't have time to do it over here, because, and now is I would give them another random list, or they would come up with another random list, or even they would come back on all the stories they actually had, and make sure they can fit them all in one of the 3 categories, right? And then when you ask them to think about divisions, but not restricting yourself to whole numbers or rational numbers, then it becomes a bit harder to fit in those categories, especially in definition 1 and 2, the line becomes blurry as you go in away from the whole numbers, all right? But again, thinking about, usually when kids see division for the first time, you usually see it with the whole numbers. And so those are the first kind of natural definitions that our students came up with. So you go. That's a quick sample. That took a good week, possibly a week and a half. All right, but they came up the definitions they came up with, and so I think that was worth it. Real quick about that class. So basically, we covered many topics from K1 to K12, random topics. We went through subtraction algorithm, a very, so division, multiplication. We also did areas, and the game was for students to come up with a definition of what you call an area. Prior to that, we had done a module on units and scales and measurements. And then they came up with the definition with area. What I really enjoyed is the definition of area was indeed very close to the definition of a measure. Did not tell them that, but in my mind, I was kind of happy. And then we also did a module on the fundamental term of calculus, and then we also did a module on the variables. What is a variable? And every time, every module were done in this way where they would have to do activities and work group and come up with a lot of examples on their own. And then from this mass of examples, try to come up with definitions. So they define areas, they define divisions, they try to define a variable. It's really hard. And so on and so on. And so our goal is, for my colleague and I, is to come up with more modules that we're going to have to work on so that we can have about 3 classes eventually. So it was a hodgepodge of all those topics. We would like to have a class where we're covering only topics for elementary teachers, 1 class for middle school teachers, and 1 class for high school teachers. That's our goal. So this was the first time we did that class. We're in the process of making it official to have it offered every year, but we're also in the process of trying to multiply it by 3. All right. So I guess I'll stop for now, and if you have any questions, please feel free.
Hi, I'm Allegra. She's laughing at me. I keep asking questions. I'm wondering what you feel, I'm wondering how these students' prior IBL experience might have impacted their success here, as well as their prior mathematical experience. Because I look up at the board, and I wouldn't say that what we got at this point necessarily would have been enough to generate what they did.
Right, absolutely. So as I mentioned, again, they had many, many more examples. So when I come to I didn't come as prepared, and also for travel purposes, but we have huge papers all along the class, on the walls along the classroom, and so we had many more examples that allowed them to, to do a bit more thinking there. As far as what their previous IBL experiences were, most of them, none. All right, but they really were, even though we made it clear in the syllabus that's how the class was going to be, I think 1 person dropped after a week, but everybody else was in. The teachers were in, for sure, not a problem, actually. But the undergraduates actually didn't have a problem with that too, even though they had no exposure to IBL before that. And as far as the math background, so again, most of the students were math, I would say half were math majors, and then up to 1 business major, the other ones were math minors. And actually, all of them, I think, had not had anything besides calculus 3 yet, multivariable calculus at that point. I think 1 had linear algebra, and that was about it. But the topics we covered, I think, were also very varied in that class. I think, the main thing to me was to see them, when they did areas, I mean, it was amazing to see them thinking hard about, that's right, what's an area? And then from there, they're like, well, what's the length? Go for it. It was different. Just in case if you want, so we've been developing these modules with my colleague, and so just you're going to brought a few samples, 1 on the area actually, and 1, the entire module. So this describes the materials needed, the material covered, the goals, the activities, and the homework. And so we're hoping to have, so we already have more, obviously, all the ones we did for that class this semester, and we're hoping to have many more in the future to target the different group of teachers. No. So far, so if you really want, so we're still working on them, and we just finished them for the first semester. So they're not online yet, but we're hoping that at some point we will put them all. At this point, you should feel free to email me, and we'll be happy to send you a PDF file. Or you can actually take one of them right now. For those ones that I brought, we have some more.